Hello friends, welcome back to my channel Chemistry with DB. Recently I have posted some videos on transition metals, stereoisomerism and the chelate effect. So I thought that I would explain some of the basic concepts behind these and the definitions which are very often asked in the exams. So we are going to deal with these particular things: transition metal, ligand, coordinate bond, complex ion and coordination number. So first of all, the definition of a transition metal, it's an element which can form at least one stable ion with a partially filled d subshell. Now when we say partially filled, that means it should be partially empty and partially filled. It should not be empty, for example 3D, like in case of scandium 3 plus. This is why scandium is not a transition metal. Neither it should be full, like 3D10, and for example in case of a zinc 2 plus ion. So this is why scandium and zinc are not transition metals, because they form only one ion, and that is with a empty 3D0 or a full 3D10. Next is the concept of ligands. So definition of a ligand is it's a species with a lone pair of electrons which can be used to form a coordinate bond with a metal ion. That metal ion could be transition metal or any other metal also. There are three different types of ligands: monodentate, bidentate, multidentate. Here it helps to get this in terms of the dent part here. Dent is, as you know, it's a tooth. So if you can imagine the lone pair as the tooth with which the ligand hangs on to the transition metal or any other metal, then it will be very easy for you to understand the concept of a monodentate, bidentate or a multidentate. Now the monodentate ligand is a ligand which uses one of its lone pairs to form one coordinate bond with a metal ion. For example, water. Now oxygen has got one lone pair here. In hydroxide ion also oxygen has a lone pair. In ammonia, nitrogen has a lone pair of electrons. In case of Cn minus, carbon has a lone pair, and chloride ion, bromide ion, iodide ion. So all of these are monodentate ligands because they use one lone pair to form one coordinate bond. Second is the bidentate ligand. Bi is two, so that means it uses two of its tooth to hang on to the transition metal or a metal ion. So a ligand which uses two of its lone pairs to form two coordinate bonds with a metal ion. So two coordinate bonds per ligand, that would make that ligand as a bidentate. Examples are ethyl diamine, wherein nitrogen, there are two nitrogens and these both nitrogens have got one lone pair each, which it uses to form two coordinate bonds per ligand. Similarly, ethane dioate ions, so you can see that oxygen has got two lone pairs, two oxygens and two lone pairs. So these can form two coordinate bonds per ligand. Next is multidentate ligand or polydentate ligand, and the example of where this is one is which uses more than two lone pairs to form many coordinate bonds. At A levels, you will be looking at a hexadentate ligand, which is EDTA 4 minus, which uses six of its lone pairs to form six coordinate bonds with a metal ion. So structure of EDTA, it's supposed to, it seems to be complex, but it's not, because if you look at the full form of EDTA, it's ethyl. Ethyl means these CH2 CH2, diamine because it has got two nitrogens here bonded to alkyl groups, and tetraethanoate ions. So these are the ethanoate ions. So there are four of these. So therefore it's ethyl diamine tetraacetate. Now in this one you have four lone pairs: 1, 2, 3, 4, 5 and 6. 6 lone pairs here. So these 6 lone pairs are used to form 6 coordinate bonds with a metal ion. This is why this EDTA is known as a multidentate ligand. Now next is the concept of a coordinate bond. Now you know a covalent bond is formed when each atom provides 1, 2 or 3, but equal number of electrons are provided by each atom to form a covalent bond. Co means sharing. Coordinate bond, on the other hand, it's also an electron sharing arrangement, but both electrons are provided by one atom only. One is just the recipient. For example, in case of ammonium ion, you can see that there are three of these are the covalent bonds, and there is one coordinate bond. Coordinate bond is always shown as a arrow going from the donator to the recipient. Complex ions, a metal ion surrounded by ligands forming coordinate bonds with its vacant d orbitals. For example, this is a complex of silver with two ammonia ligands forming a this ammoniacal silver ion. On the other hand, you have a copper ion, Cu2 plus ion, forming a complex with 6 water ligands. Here, cobalt ion has got a complex forming with 6 hydroxide ligands, and in this one, copper ion, copper 2 plus ion, forming 4 coordinate bonds with 4 chloride ligands. These are all examples of complex ions. Coordination number, it's the number of coordinate bonds that a particular metal ion has formed with ligands surrounding itself. Now, for example, if let's look at this one. In this case, Ag plus has formed a complex with two of these ammonia ligands forming coordinate bonds with it. So that I have shown as the arrows. So this here silver has formed two coordinate bonds, so therefore the coordination number is 2. In the next example, this one, copper has formed 4 coordinate bonds with 4 chloride ligands, so therefore the coordination number would be known as a 4 and shape would be tetrahedral here. And in the next example of iron 2 plus, here it has formed 6 coordinate bonds with 6 water ligands, so therefore the coordination number is 6 here. I hope this video was useful in explaining the basic concepts, and if you like this video, then please like, share and subscribe, and I look forward to seeing you on my next video. Bye. Take care.